wave-particle duality. Have you ever truly looked at your hand? I don't mean just a glance. I mean, have you ever stopped and really looked at it? The lines on your palm, the tiny hairs, the light catching your skin. It feels solid, doesn't it? Real, substantial. You can clench it into a fist. Feel the pressure of your fingers. This is the most fundamental truth we know, the world of things, of objects. But what if I told you that this solidity, this thingness of everything around us is a magnificent, cosmic illusion? What if the universe, at its very heart, is playing a game with us? A game of peekaboo on a grand scale. And the rules of this game are governed by the most beautiful, the most baffling, and the most magical concept in all of science: wave-particle duality. This isn't just a dry scientific principle, this is the secret language of reality itself. And today, we're going to learn to listen. To understand this grand illusion, we need to travel back in time, not too far, to the 17th century. Here, two intellectual giants were locked in a battle over the very nature of light. On one side, we had Isaac Newton, a man who gave us laws of motion, gravity, a man who believed in a universe of solid, predictable things. He looked at light and said, "Of course, it's made of particles, tiny, invisible corpuscles, streaming from a source like a microscopic bullet hell. They travel in straight lines. They bounce off mirrors. They explain the sharp shadows we see." It was clean. It was logical. It fit a world of things. On the other side was Christian Huygens. He proposed something far more ethereal. He said light is not a particle, but a wave. Think of the surface of a still pond. You drop a single stone, and what happens? Ripples spread out. A wave isn't a thing you can hold. It's a disturbance, a vibration traveling through a medium. Huygens said light is like that, a wave vibrating through an invisible cosmic jelly he called the luminiferous ether. Waves explain things particles can't, like how two beams of light can cross and create beautiful patterns of interference, like ripples on a pond meeting and creating a new, complex dance. For over a century, this was the stalemate. Particle versus wave. Two competing visions of reality. And for a long time, Newton's reputation was so immense that his particle theory won the day. The universe, it seemed, was made of tiny billiard balls. But the universe had other plans. The first crack in the particle universe appeared in the early 1800s with a brilliant, simple experiment by a man named Thomas Young. It's called the Double-Slit Experiment. And I want you to imagine this, because it's where the magic begins. Imagine a wall with two thin, parallel slits cut into it. Behind this wall, we have a screen that lights up when something hits it. Now, we take a machine that fires tiny, indestructible pellets, pure particles, at the slits. What would we see on the screen behind? If you think of particles like bullets, they would either go through the left slit or the right slit. We'd see two bright bands on the screen directly behind the two slits, right? Simple. Now, let's do the same with water waves. We have a water tank, and we send a steady wave towards the two slits. What happens? The wave passes through both slits at once, and on the other side, the two new waves from each slit spread out and crash into each other. Where a peak meets a peak, they create a super big peak. Where a peak meets a trough, they cancel out. The result isn't two bands. It's a beautiful, stripy pattern of many bands, called an interference pattern. This is the undeniable signature of a wave. So, we have our test. Particles make two bands. Waves make many bands. Now, for the moment, that shattered physics forever. They did this with light. They sent a beam of light, tuned to a single color, towards the two slits. They turned off Newton's bullet theory, and they turned on the detector screen. What did they see? They didn't see two bands. They saw the stripy, multi-band pattern, the interference pattern. The universe had spoken. Light was a wave. Huygens was right. Scientists cheered. The case was closed. But the universe was just getting warmed up. It was setting a trap. Fast forward to the dawn of the 20th century. A new mystery was brewing. Scientists were studying the photoelectric effect, a fancy name for what happens when you shine light on a metal and it kicks off electrons. According to the wave theory, any color of light, if it were bright enough, should eventually kick off an electron. But that's not what happened. Only light of a certain color, a certain energy, could do the job. And making the light brighter didn't change that. It was like a lock that only responded to a very specific key, not to someone just shouting at it really loudly. This made no sense for a wave. And then, a young patent clerk named Albert Einstein looked at this problem and proposed something outrageous. He said, what if Newton was a little bit right? What if light, when it interacts with matter, does so in little, tiny, packeted chunks? Little bullets of energy. He called them quanta of light. We now call them photons. The physics community was aghast. How can light be a wave and a particle? It's like saying something is a piano and a cheeseburger at the same time. It's nonsense. But the evidence was there. So, someone, in a moment of pure genius, or perhaps madness, decided to perform the ultimate test, the double-slit experiment, but with a terrifying twist. They decided to fire a single photon of light at a time. Let that sink in. They would send one single, solitary particle of light towards the two slits. They would fire it, wait, then fire another. There is no other photon for it to interfere with. It's just one tiny bullet. Common sense screams, it must go through one slit or the other. It should, over time, paint two bright bands on the screen behind. They turned on the machine. The first photon hits the screen. A single dot appears, then another, then another. They're collecting data, one single photon at a time. And as thousands of these dots accumulate, a pattern begins to emerge on the screen. It wasn't two bands. It was the interference pattern, the stripy, multi-band pattern of a wave. How? How is this possible? A single photon is fired. It is a localized thing, a dot on the screen. But to know where to land, to create that interference pattern, it must have, somehow, passed through both slits at once. It must have interfered with itself. It's as if the photon ceases to be a particle for its journey and becomes a wave of possible locations, a ghost of probability, exploring all paths simultaneously. It goes through both slits, it goes around the edges, it even, in a mathematical sense, takes paths that go to the moon and back. All these possibilities, these phantom paths, interact and interfere with each other. And at the very last moment, when it strikes the screen, this phantom wave of possibility collapses into a single, solid, real point. A particle again. The act of observation, of measurement, forces the photon to make a choice, to become a thing. This isn't just true for light. They did it with electrons, with atoms, even with large molecules. They all do the same thing. Every single thing in the universe has this dual nature. It is both a solid particle and a spread-out wave of potential. The universe is not made of stuff. It is made of potential. It is made of questions. And the answer you get depends entirely on how you ask the question. If you ask, which path did you take? By setting up a detector at the slits, the photon will obediently behave like a particle and go through one slit or the other. The magic is gone. The interference pattern vanishes. But if you don't ask, if you just let it be, it remains a shimmering cloud of maybe, a ghost in the cosmic machine, exploring the infinite possibilities of its existence. So, let's return to your hand. What does this mean for the solidity you feel? It means that the atoms that make up your hand, the electrons whizzing around their nuclei, they are not tiny, hard planets. They are clouds of probability. They are waves. When you touch the table, it's not really one set of billiard balls hitting another. It's an immensely complex interaction of these probability fields, these waves, repelling each other. The solidity is a sensation, an emergent illusion from a deeper, fluid, and dreamlike reality. You are not a collection of things. You are a localized vibration in a field of infinite potential. You are a standing wave in the cosmic ocean, temporarily believing yourself to be separate from the water. This is where science touches the mystical. The observer is not separate from the system. The act of looking, of being conscious, is intimately woven into the fabric of what we call real. We are co-creators of our reality, not just passive observers. The ancient mystics and sages spoke of Maya, the illusion of the phenomenal world. They spoke of a unified, interconnected cosmos. Wave-particle duality is the rigorous, mathematical, experimental proof of their deepest intuitions. The solid world is a dance, and we are both the dancers and the audience. So, what is the universe? Is it a collection of objects, or is it a tangled web of vibrating energies, of possibilities, waiting for a conscious mind to give it form? The answer, miraculously, is both. This journey into the heart of reality is one we've only just begun. The implications are staggering, and they point to a universe far stranger, far more holographic, and far more conscious than we ever dreamed. If your mind is buzzing with these ideas, if you feel that sense of wonder, then you're exactly where you're meant to be. If you enjoyed this deep dive, do me a huge favor. Smash that like button and subscribe to the channel so we can continue this exploration together. What part of this boggles your mind the most? Let me know in the comments below. I read every single one. And for those of you who are truly ready to fall down the rabbit hole, who want to explore how this duality weaves into the nature of time, consciousness, and the very structure of a multiverse. I've written a book that expands on these very ideas. It's called Holographic Multiverse. And in it, we take these quantum mysteries and build a vision of a reality that is literally constructed from information and perception. It's a wild ride. If you're interested, the link is in the description below. Thank you for watching. Remember, the world is not what it seems, and that is its greatest magic.